Hello, sir.
Yeah, I'm audible?
Sir, your voice is too low.
Okay. Check your volume.
Sir, my volume is full.
Okay, 1 minute. Now check it. Is it okay now?
You're audible, sir. Yes, sir. No. Yes,
Now I'm audible. Okay.
yes, sir.
Okay, screen is visible to you?
Yes, sir, screen is visible, sir.
Okay. Okay. So in the last class we discussed about what was the last topic that we covered?
So we need to discuss about electric fields.
Electric field. Okay. So electric field intensity we already discussed the formula of electric field intensity. Talking about the electric field. Okay, good. Okay. So okay. You can start with this question. If you know the process, just tell me quickly what you will do. Then we'll go to the next. Pentagon is there. On four vertices of pentagon, equal charge is placed. They are asking you what will is the electric field at the center. What you'll do.
Sir, addition we can get now.
Yeah. What you'll do?
Sir, by vector addition we can get now, sir.
Huh. Okay. So you will find the electric field due to all the four, and then you will add vectorially, right?
Yes, sir.
Think if uh, charge is placed on all the five corners, then what will be electric field at the center?
Sir, charges.
Placed on all the five vertices, then what will be electric field at the center? If charge is placed on all the five vertices of the pentagon, then what will be the electric field at the center? So it is a regular pentagon. If equal charge is placed on all the five
It
vertices
is
of
zero now,
pentagon,
sir. It will be.
it will be zero.
Yes, sir.
Now one charge is removed from one vertex. So charge is there only on four vertices. What will be the electric field at the center?
Sir, due to electric field due to charge of one atom only, no, so one charge.
Yeah, understood.
Yes, sir, understood.
Okay. Okay. So now you can try this question. You can just explain the process, what you will do, how you will do. Understood the question?
I said understood.
Okay. So what you will do now? So the block is present in an electric field and the block is charged. So that block will experience an electrostatic force. Charge is positive, so it will experience force in the direction of the electric field. It will move d distance, collide with the wall, again return back. While returning back, it will experience force in the opposite direction of the motion, so it will slow down and finally stop. Understood? Do it fast. Or you have any doubt, you can ask quickly.
The ball, the block here does not undergo SHM.
Hmm. Okay, it is not SHM, right?
Yes, sir.
And how you will find the time period?
Sir, by using V equals to U, V equals to U plus A is equations of motion, we can get.
Uh, by using V equal to U plus AT, how you will get? You don't know V and you don't know T. Both are unknown.
The U is 0, sir.
U is 0. You have two unknown, V and T. How you will, what you will get from this equation then? V equal to U plus AT. So you will not use V equal to U plus AT, right?
Sir, if we use S equals to U plus 80, so then in
Hmm.
time taken
Okay. Okay.
to the
Correct.
equations.
Yeah, this is not SHM. Just you will use equations of motion. Why you are using equations of motion? Because the motion is uniformly accelerated, right?
Yes, sir.
Okay. Go for this question. So this is from your class 11th derivation SHM, right?
Yes, sir. By
Yeah. So
finding acceleration and we can do now. Solve
yeah,
problem.
there is a G effective formula, no? That you can use 2 pi under root L by G effective, right?
Yes, the 2 pi root elements here.
Okay. So you can try this question. Again, there is an electric field.
Come on.
Tell me, Himanish, what you will do here. So again here continuously a force is acting in downward direction. Electrostatic force.
Applying conservation of energy considering electrostatic force depending atmosphere. Means potential will come no sir in the electrostatic potential.
Electrostatic potential will come. So yeah, yes. Uh,
Formula of
you can say that
potential.
the change in electrostatic potential energy is equal to negative of work done by the electrostatic force, right?
Yes sir.
Hmm. So in addition to change in gravitational potential energy, there will be change in electrostatic potential energy also.
Yes sir.
Gravitational force, electrostatic force, both are acting in the same direction, right?
Yes sir.
And what is the condition to complete the vertical circle? Condition is that at the topmost point, its velocity, its tension should become zero at the topmost point, not before reaching topmost point, right?
But if the tension is not zero before after topmost point, what happens sir?
If tension becomes zero before reaching topmost point, then it will lose the circular path because, are you getting? A string will become loose.
Sir, sir, at the topmost point, the tension should not. Tension should not be equal to zero, no sir.
Means tension should be zero just at the topmost point, not before reaching it. Just zero becomes zero only at that particular point. Because even if tension becomes zero at topmost point, then mg and qe will provide the required centripetal force. Are you getting?
Sir, even
Mg,
if your tension is there also, then we can provide
but
centripetal force, no sir.
yeah, yes, but then we have to find the minimum, u minimum. So for minimum velocity case, you are giving minimum velocity here, not the maximum velocity, minimum. So slow, the minimum possible velocity you are giving so that it completes. So then it should slow down, slow down, slow down, slow down. Here its velocity will become minimum. Are you getting? In the whole path, where its velocity will be minimum, tell me. Charge particle, topmost point.
Sir, we can take it minimum can be zero, no sir.
No, minimum velocity cannot be zero because if minimum velocity is zero, then even before reaching top, it will its tension will become zero, and then it will lose circular track. It cannot continue in circular track if tension becomes zero before reaching topmost point. Are you
Yes
getting?
sir. Yes sir, I'm getting.
Yeah. So yeah, a speed cannot become zero because even before a speed becoming zero, tension will become zero. So the condition is that to just complete the circular motion, here the tension should be zero. You can look at this equation mathematically. Also, you will understand that v has to be minimum. Now this is fixed and this is fixed. Only this is variable, na t. Are you getting?
Yes sir, I'm getting.
So at t zero only this will be minimum because the other two quantity cannot change QE and mg. They have constant value. So then putting t equal to 0, you are getting this equation. Now you will use work energy theorem. From that, again, you will get some relationships using combining both the equation. You get something. Okay. So now you can try this one. Are you getting? You understood the question first? Are you there, Himanish?
No, I'm getting, sir. Yes, sir.
Okay. So then what you'll do?
You can apply equations of motion on the mass.
Okay. So you will use the equations of motion.
Motion, yes, sir.
Just tell me few concepts. What you will do here? Like determine the speed at which it strikes the opposite plate and from where it is starting. Okay, this. Oh, this is very simple. Okay, so gravitational force and electrostatic force both are in the same direction.
Yes, sir.
Okay. This is very simple. Like uniformly accelerated motion, right? You'll use equations of motion. That's it. In addition to gravitational force, you will consider the electrostatic force also. And then because the acceleration is constant, so this is simply a motion in a straight line that. You can also use work energy theorem, right? Think, can
We
you
can
use
use
work energy theorem?
internal forces. Yes, sir, we can use, sir.
Yeah. In work energy theorem, you have to consider work done by all the force. No need to worry about internal, external, these things. It simply says work done by all the force is equal to change in kinetic energy. All means all. Internal, external, conservative, non-conservative, pseudo, all. But there are only two forces and both are conservative here. So it works, work energy theorem works in all the situations. Okay, now you can try this one. If you can do it quickly, you understand the concept. If there is nothing new, you have already done this type of question. So then don't waste a lot of time. Just directly tell me the process. We'll go to the next. Focus more on doing different type of questions so that you understand the application of concepts better. So here electric field is not constant, right?
Constantly it's varying.
That is the only thing.
Integration method. Yes, sir.
So electrostatic force will vary. So then calculus will come, right?
Yes, sir.
So now you simply see, are
Integration.
can you, yeah, the distance traveled by the particle till it comes to rest. So just write the equation. What you'll do?
So you can say integral electric field intensity by second time.
Integral. Yeah, tell me. Integral. You have to write the equation. Tell me the concept. What you will use here. Which formula, which equation, which theorem, which law.
So first I will find the acceleration, sir.
Okay.
In one, we get, I think, in terms of x only we get no sir, acceleration if you find. And from that acceleration, we know v dv by dx one method.
Okay. So V dV by dx, you will write. Huh? Can we do it by work energy theorem?
Work. Yes, sir, we can do, sir.
Hmm.
Yes, but also we do not want to do it.
Integration QE dx from x1 to x2 is equal to 0. Change in kinetic energy 0, no?
Yes, sir.
That's it. Ax minus bx square by 2 equal to 0. Got the value of x. Will not get. See here, even after solving, you are getting the same thing now. See, ax minus bx square by 2 equal to 0. You got the two values of x. So you can do it by work energy theorem, or you can also do it by writing acceleration as v dv by dx, right? See,
Yes,
this is
sir.
work energy theorem. See, this is work energy theorem. Change in kinetic energy is 0. See, this method is easy, quick. So this type of question, you should also think about work energy theorem. See, by work energy theorem, it becomes very easy. Simple integration, equate 0, got it. Now, if they are asking acceleration, just substitute the value of x in the formula and you'll get the acceleration. That's it. The formula of force is QE. E is already given as a function of x. X you already calculated. Understood? In
Understood,
second
sir.
part, I think they are asking acceleration. That's why. Second part of the question, they are asking acceleration. See, acceleration at that moment. First, you will find x, and then you, in the equation of acceleration, will substitute x, right? You have any doubt?
Right, sir.
So there are many questions of this type. Now I think you can do all these types. So just tell me the idea what you will do here. Multiple charges are there. At one point you have to find electric field. Point charges are there. So because of individual charge, you will find electric field.
Yes, sir, on
You will
time.
check their, and then you will do the vector addition, right?
Yes, sir.
Then some GP AP will be formed, right?
Yes, sir. From G.
That's it. Okay. So leaving these type of questions, going to some different question. Okay, now you can try this one. Do it fast. As shown in the figure, they are saying. So let's see where is the figure. I think this is the figure. Try this. Read question. Try to understand. Understood the question. What you have to find.
figure is given, sir.
Yeah, this is the figure. Figure is visible to you. Just tell me the process, what you will do.
So similarly, equations of motion and
Okay, so from equation of motion, how you will get theta? What you will do?
work for energy we can use this calculate.
In work for energy equation, how theta will come?
So I mean, at that point, if we use radius of curvature, we can.
No.
uh,
Suppose you use radius of curvature at that time, so then also how you will get theta? You don't know radius of curvature also. Radius of curvature one unknown, theta another unknown. How you will get? Even if you got radius of curvature, how you will link it with the theta? Think simple. Think in terms of the vector chapter concepts, basics. How we find angle?
So we divide into components and with dot
Yeah,
product of those.
yeah, that's it. So here you will just simply divide the velocity into two components. This is the angle made by the velocity vector, no, with horizontal. Just break it into two components, Vx and Vy, right? Is x component of velocity and this is y component of velocity. Vx and Vy you can find quickly, by using equation of motion. Anyway, Vx is not going to change. Are you getting? Because in horizontal direction there is no force, so Vx will be constant as u. But that uh, Vy you will find by using equation of motion, u equal to v equal to u plus at. For the calculation of t, already they have given you the length, right?
Yes,
So
yes.
length by u will be the time. Okay. Once you got Vx and Vy, then tan theta equal to Vy by Vx. That is the answer. That is the process. That is what you can do. See this, what they have done at the end, tan theta equal to, they have written. See, they have calculated Vx, Vy, and then tan theta is equal to Vy by Vx. You will get the angle made by the velocity vector with the horizontal. Is it clear? In this you have any doubt? You can ask your doubt, or you know any other way to do it, you can share that also. You should also think about doing the question. If you feel that it can be done in a different way, you should try that also. Tell me, here you have any doubt? Tell me, Himanish, what happened? Are you there?
Yes, sir.
Okay, what happened? You're not saying anything.
Sir,
Yeah, tell me.
sir, here can we